In this video, we'll talk about one-to-one functions. So as we have been in the past few videos, we'll develop a graphical intuition first for what one-to-one function might mean. Then we'll define it formally and talk about the test which you can use to identify whether or not a function is one-to-one. So let's start by considering the graphs of f, g, and h below. So each of these graphs visually looked fairly distinct from one another, and just to try to describe them a little bit mathematically to give some kind of more formal articulation of the visual properties of the graph. When we look at f, we might notice that there are many y values for a single x value. So let me write that. Multiple y for one x. Multiple outputs for the same input. Moving to the graph G in the middle, we can notice that there's a similar kind of thing going here, but maybe the converse. There's one y for multiple x's. That is, we can see at these 2 points, those have the same g value at 2 distinct x values. And this last graph, h, has one y for one x. So these are 3 distinct graphs. First one, we've got many y values, many outputs for a single input. G, we had one y value for a couple different x's, a couple different inputs. And H, we have one single y for every x. And this last one, H, is what a one-to-one graph looks like. The first one we know is not a function. The second one we know is a function, but still we might want to consider this property that has a single y for multiple x's. That is, for 2 distinct x's, we get the same output. And just as we can define for the graph f, which is not a function, the vertical line test, we can define the horizontal line test for the graph of G. So the horizontal line test would tell us whether or not a function is one-to-one, like h is over here. H, we can clearly see that there's one y value, one output for every input. Sometimes it's not as clear. So using the horizontal line test will help us to identify whether a function is one-to-one or not. So again, we've got a graph f that's not a function, a graph g that is a function but is not one-to-one, and a graph h that is a function and is one-to-one. So the definition of a one-to-one function. A function with domain A is called one-to-one if no 2 elements of A have the same image. That is, no 2 inputs have the same output. Expressed in a more mathematical way, f of x1 does not equal f of x2 whenever x1 does not equal x2. Or in other words, if f of x1 equals f of x2, then x1 must also equal x2. Otherwise, if something like this is not the case, then our function is not one-to-one. The horizontal line test. A function is one-to-one if and only if no horizontal line passes through its graph more than once. And I've got a figure here with a graph of f, which is clearly not one-to-one since it does not pass the horizontal line test.